Hello and welcome once more to Thinking Maths Further, the kind of extra little investigative videos that I thought I'd release on YouTube for students revising from their A-levels to investigate something and maybe discover something that's a little bit interesting. So yesterday I asked you to have a look at the graphs of polynomials where you had, well, factors, and these factors told you roots and what happens if you repeated roots in your polynomials. So I invited you to use Desmos, a really good free online graphing calculator for this, and said what happens if you repeat roots. So as you can see, with one factor we just get a linear root. If we get two and repeat it, we get a quadratic root, and we could maybe put a second one there. So you can see there we've got two roots, one which is repeated at x equals 3 and one which is a normal root at x equals 4. But what happens if instead of being a power of 2 we put a power of 3 in there? Well, what we can see there, if I just change that to plus 4 so we get a bit more visual, is that we've actually got at x equals 3 a kind of triple root. It's doing what the graph y equals x cubed does. Just there. So you can see that what's happening at that cubed root is it's kind of making the same shape as y equals x cubed. So what if I decided to I don't know, square this bracket with a root of 4? What you can see there is it's kind of doing a quadratic style shape, a curve that touches and goes back down. And I mean, we could go really crazy. We could put another one of these in somewhere and put kind of x plus 1. Oh, hang on, that's in the power, don't want that. X plus 1 at the end. And we get a linear thing going on. And so I thought that was some quick investigation that would probably help those of you who are working on sketching graphs, but was also kind of quite interesting too, to see how it worked, what happened and what different changes did to the graph. So hopefully you were at least mildly interested by that. If not, well, more shame you. Cheers very much. So another test or another task or another idea that I thought would be quite nice to investigate, slightly trickier this one, involves a bit more A-level skill, is to look at discriminants and derivatives. We know that quadratic functions have this thing called a discriminant, found by doing b squared minus 4ac. We also know that the value of the discriminant informs us how many solutions equal to 0 the quadratic has. And finally, another thing we know is that if we've got a cubic function, when we differentiate it, it leaves us a quadratic. But what does the discriminant of the derivative of a cubic tell us about the cubic? So if we think then, if we started with something like 3 times x minus 5 squared plus 2, that's a quadratic, and I know it has no real roots. I've been quite deliberate in what I've chosen there. I've chosen to have a 3 outside these brackets so that when I multiply it out I end up with 3x squared, so when I integrate it I get an x cubed. And of course I've very deliberately put the plus 2 at the end, so I know I've got no real roots, I know I've got a minimum point. Now by expanding that, okay, I'll get 3x squared minus 30x plus 77. And then if I integrate that I get x cubed minus 15x squared plus 77. So what I'm going to do now is graph that in Desmos once more. So I'm going to use Desmos, I'm going to graph that. So we had y equals x cubed minus 30x. No, hang on, that's not right. Minus 15x squared. 15x squared. And finally final term I want there is the plus 77x. And so you can see what I've got there is a cubic function that looks, for all the world, not far off a straight line. So not the lumpy humpy type of cubic that we quite often see and get asked to sketch in A-level questions, but a cubic which is very much close to being a straight line. It's always going up. And what I suggest you do now is maybe try doing this with a few others. Maybe try some other functions that have no real roots, other quadratics that have no real roots. Integrate them and graph them and see what happens. Try one which has two different real roots. Expand it, integrate it, see what it looks like. Try some which have equal roots. Expand it, integrate it. Look at the graphs and kind of think, well, what does the kind of discriminant, the number of roots of the discriminant, tell us about the graph of the cubic? So you'll be practicing a bit of integration and practicing expanding brackets, understanding completing the square and all kinds of stuff, and we'll be discovering a little fact, a little nugget, a little connection that hopefully you'll find quite interesting.